All right, let's do some differential equations. These are linear equations, and they're not bad at all. All right, so let's see what we've got here. We've got it said we've got definition of a linear equation. It says a first order differential equation of the form a1 of x dy dx plus a naught x y equals g of x is said to be a linear equation in the variable y. Okay. Standard form. By dividing both sides by the lead coefficient a1 of x, we obtain a more useful form, the standard form of a linear equation. And so basically what we're doing is we're dividing everything by a1 of x, like up here, a1x, a1x, and a1x. And so of course that would cancel and that would leave us with the dy dx. And then we're just calling this a naught x over a1x, we're calling that p of x. And then the g of x over a1x, we're calling that f of x. Okay. This is the form that we want it in when we're solving a linear first order equation. Okay, that's the form you need to get it in. Okay, I mean the problems that you come across may not be in that form, but you have to get it in that form. And so let's look at the method for solving a linear first order equation. It says put the equation in standard form, which we know how to do that now. It's that. We've got to have just dy dx here. And then we've got something times y equals some function. All right. From the standard form, identify p of x, which p of x is just the term in front of y, and then find the integrating factor. The integrating factor is e raised to the integral of p of x dx. So we're going to integrate this p of x here with respect to x, and that's in the exponent here of this e term. No constant needed in evaluating e to the px dx. And then we multiply both sides of the standard equation by the integrating factor. Okay, so basically all we're doing is we're taking this term right here, whatever we get here, and we're multiplying it times each term in standard form. Okay, the left hand side is automatically the derivative of the product of the integrating factor and y. So after you multiply this side right here, each term by the integrating factor, we can rewrite that as the derivative of the integrating factor times y with respect to x. And I'll show you how that works out. I'll show you in one of the examples. And then we've got the integrating factor times our function f of x. And then we integrate both sides and solve for y. Okay. All right, so let's look at some examples. All right, so we can see that this one right here is already in standard form. We got the dy dx, and then we've got minus 3y equals 0. So we've got p of x is equal to negative 3. That's the term in front of y. Remember, the standard form, and I'll just write it here, dy dx plus p of x y equals f of x. And you can see p of x, that's the term in front of y. And then we have our integrating factor is e raised to the integral negative 3 dx, and that's going to be e to the negative 3x. That's our integrating factor. All right. All right, so now let's multiply each term in the standard form by the integrating factor. So that's going to be e to the negative 3x dy dx minus 3e to the negative 3x y is equal to 0. Okay, we multiply this times the first term, this times the second term, and then this times the 0. All right, and then this left-hand side here, remember what it said. It becomes the derivative of the product of the integrating factor and y. Okay, every time, whatever your integrating factor is, it's that integrating factor times y, and it's the derivative of that product. Now let me show you how that works out. I'll show you on this one. We're not going to go through it on all of them. But let's just say we take the derivative of this. We've got the derivative with respect to x of e to the negative 3x y. So this is product rule. So the derivative of that is going to be the derivative of the first term times the second term plus the first term times the derivative of the second. We're taking the derivative with respect to x, so that would be dy dx. Okay, and I mean, you can see it's not written in the same order here, but it's still the same thing. See, you got e to the negative 3x dy dx, and then you've got the minus 3e to the negative 3xy right there. And basically all we're doing, we're just rewriting this as the derivative of that product there. You can see from this, it's the same thing. Okay, and that's how it works out every time. Okay, works out like that every time. All right, so now we need to integrate both sides. So we've got d dx e to the negative 3xy dx equals the integral of 0 dx. And so the integral and this derivative, that just kind of cancels each other out, equals, and then this, the derivative 0, that's just a constant term. And so then what does it say to do? It says solve for solve for y. So we get y equals c e to the 3x. And that's going to hold true. Whoops. Where x is between negative infinity and positive infinity. Now let me just show you real quick how I get this, because I mean this is pretty standard. I mean, I'm sure you can do it in your head, but in case you're not seeing it, I will show you one time. So we're dividing both sides by e to the negative 3x. So those cancel. I get y equals, and then I'm going to move this up, and that just changes the sign of the exponent when you move it up, and that's where that comes from. So I mean, you can see this. It's not difficult to solve these things. They're really pretty easy. The most difficult part probably is going to be on some of the integrals that you have to do over here on this side. Okay, but I mean, this one was easy. All right, so let's look at this one. So looks, same problem, just about, but this is not 0 here. This is we've got a number there. All right, so just real quick, because I mean the integrating factor is going to be the same as the other one, because p of x is p of x is the same thing. It's negative 3, but we'll go through it. We'll write it out. So p of x is equal to negative 3. Our integrating factor is e to the negative, is the integral e to the negative 3 dx, which is e to the negative 3x. And then we're going to multiply the integrating factor times each term. All right. And so remember, the left-hand side becomes the derivative of the product of the integrating factor and y. All right. So there you have it. So now we integrate both sides. That's e to the negative 3xy dx equals integral 6 e to the negative 3x dx. And so here we get e to the negative 3x y is equal to, now when we integrate this, that's going to be 6, and then the integral of e to the negative 3x is e to the negative 3x, and then you're going to multiply by the reciprocal of the coefficient of x times negative 1/3 plus c. So this is e to the negative 3xy is equal to negative 2 e to the negative 3x plus c. Now, let me just come over here real quick, just real fast, because you should know how to do this. Let's just integrate this. Okay, remember how you did that? You would use u substitution. U equals negative 3x. du is negative 3 dx. So we need a negative 3 out here. So we got to multiply by negative 3, come out and multiply by negative 1/3. So that's going to be negative, that's negative 1/3 integral e to the u du when we make our substitution. And so that's negative 1/3 e to the u, which is going to be negative 1/3 e to the negative 3x. Okay. And so that's where this part comes from. Just real quick. Okay. You should be able to do that in your head, but in case you were confused about it, I just went ahead and showed you. All right. And so now we're going to divide everything by e to the negative 3x. All right. And so we're going to get y is equal to negative 2 plus c e to the negative 3x. Okay. And that's going to be where x is between negative infinity and positive infinity. All right. And so these first two problems that we solved, we found the general solution of these differential equations, linear first order differential equations. All right, so now let's look at this example and another one, and then let's talk a little bit more about solutions. Notice how I put the x's from negative infinity to positive infinity. Let's talk about that a little more after we work these two problems here. All right, so we got to get this in standard form. So we've got to multiply each term by x. So that's going to give me dy dx minus 4 over xy equals x to the 5th e to the x. I just divided. I don't know. I can't remember. I might have said multiply. If I said multiply, I meant divide. If I said divide, then forget I said that. Divide each term by x. Okay. And so now we've got p of x is equal to negative 4 over x. And then our integrating factor is e integral negative 4 over x dx, which is equal to e to the negative 4 natural log of x, which that's going to be e to the natural log of x to the negative 4. All right, we can just move that up. And so that's going to be x to the negative 4. And we're going to say x is greater than 0, because you can't take the natural log of a negative number, can you? I mean, notice we didn't use absolute value, we used parentheses. All right. Now, we're going to multiply each term by the integrating factor. Okay. All right. So I've got x to the negative 4 dy dx minus 4 over x times x to the negative 4 y equals x to the negative 4 times x to the 5th e to the x. And so this is going to give me d dx, and that's going to be the integrating factor times y equals, and then this is just x e to the x. All right, and then we're going to integrate both sides. D dx, x to the negative 4y dx is equal to the integral x e to the x dx. So the left-hand side becomes x to the negative 4y equals, and now to integrate this, you should be able to do this. This is a pretty easy one. We'll come over here and we'll do it here. X e to the x dx. So u is equal to x. dv is e to the x dx. du is dx. And v is e to the x. That's right. We're going to do integration by parts. And so that's going to be x e to the x minus the integral e to the x dx, which this is going to be x e to the x minus e to the x plus c. Okay. All right, so this is going to equal x e to the x minus e to the x plus c. Well, let me change colors back. That's x e to the x minus e to the x plus c. So there we have it. All right, and now we're going to divide everything by x to the negative 4. Okay, we can do that. Or, I mean, basically we want a 1 here, right? So, I mean, if you wanted to, instead of dividing by x to the negative 4, we could multiply everything by x to the 4th, because x to the 4th times x to the negative 4, that would be x to the 0, right? X to the negative 4 plus 4 is x to the 0, which is 1. Okay, so we're going to get y is equal to, that's going to be x to the 5th e to the x minus x to the 4th e to the x plus cx to the 4th. Okay, and that's going to be from 0 to infinity. All right, so I'm going to come back and talk about this a little more after we work the next problem. I'm going to write a bunch of stuff down to kind of clear this up for you. All right, now let's look at this one. They want us to find the general solution of this. So let's get it in standard form. So we're going to divide everything by x squared minus 9. So that's going to be dy dx. All right, and then that's going to be plus, that's going to be x over x squared minus 9 times y equals 0. All right. All right, so let's identify p of x. That's going to be x over x squared minus 9. And then we're going to do our integrating factor. That's e raised to the integral x over x squared minus 9 dx, which that's going to be e to the 1/2 natural log of x squared minus 9. All right, which this is going to be e to the natural log. All right, and that's going to be the square root of x squared minus 9. We move the 1/2 up, that's x squared minus 9 raised to the 1/2, which is the same thing as the square root. And so that's the square root of x squared minus 9. All right. Now, let's notice that p of x here is continuous from negative infinity to negative 3, negative 3 to 3, and let's see, and 3 to infinity, right? because we can't have 0 in the denominator of a fraction. All right. So now let's go ahead and multiply each term. We got square root x squared minus 9 times dy dx plus, and then that's going to be x square root of x squared minus 9 over x squared minus 9 y equals 0. And so this is going to give us the derivative of the integrating factor times y, and that equals 0. All right. And so if we integrate this, we get dx square root x squared minus 9 y dx times the integral of 0 dx. And so that's going to give us the square root of x squared minus 9 y equals c. All right. And so we get y is equal to c over x squared minus 9. And we're doing this from negative infinity to negative 3 or 3 to infinity. Okay. And so there's your solution. All right. So let's talk about these intervals here that I've been given. So let's write this out so you can see it. So let's notice now let's call this example 2. Well, let's see, this would actually in here would be actually the 4th example. So we'll call that example 4 and this one example 3. Okay, because we did 2 other examples before that. I don't want you to get confused, 1 and 2 being the first 2 we did. But example 4 and example 3. So what's going on? It's supposed to be erasing. There we go. So in example 4, okay, in example 4, notice in example 4 that x equal 3 and x equal negative 3 are singular points. Okay. All right. They're singular points. That, see right here, where is it? See, that would be undefined there at 3 and negative 3. You see that? All right. And I talked about singular points in another video. I think it's the video right before this one we talked about them. So you can go check that out. Of the equation, and that every function in the general solution y equals c over the square root of x squared minus 9 is discontinuous at the points. Okay, and you know, we use this interval and this interval. Well, the natural log, you see that the natural log of any of these values here, you couldn't take the natural log of a negative number. I know we used absolute value, but we're going to use these values here where this is positive. Okay. All right. Now, so let's notice x equal 0 is a singular point in example 3, but the general solution, y equals x to the 5th e to the x minus x to the 4th plus cx to the 4th, is noteworthy in that every function in the, see, this is the solution to example 3. In the one parameter family is continuous, right? Every function in this is continuous. It's just a polynomial, right? Is continuous at x equal 0. Okay, so the solution is continuous at x equals 0. X equals 0 is a singular point. And is defined on negative infinity to positive infinity. It cannot be considered. So we're saying this solution here wait a minute, let's see. And is defined on that let's see. It's noteworthy that every function in the one parameter family is continuous at x equals 0 and is defined on that, and not just on 0 to infinity. Because remember, we did 0 to infinity in that last example. However, y equals x to the 5th e to the x minus x to the 4th e to the x plus cx to the 4th on negative infinity to infinity cannot be considered the general solution of the differential equation, because the singular point x equal 0. All right, because where is it? I mean, you see here the p of x is, it's undefined at 0, right? Okay. All right, so I just wanted to kind of mention that just a little bit, but yeah, that's really all it, that's all it is. All right, so let's look at this. Let's look at an initial value problem. See, they tell us that y of 0 equals 4 here. So let's solve this. This is already in standard form. So I've got p of x is equal to 1. Our integrating factor is e to the 1 dx, which is e to the x. And then I'm going to multiply each term by the integrating factor. And so remember, the left-hand side becomes the derivative of the product of the integrating factor and y. All right. All right, and so now we're going to integrate both sides. All right, and so we get e to the x y is equal to, now, I showed this earlier. We integrated that one by parts earlier, so I'm not going to do it again. X, e to the x minus e to the x plus c. Okay. And so remember, we had y of 0 equals 4, y of 0 equals 4. So, I mean, we can actually just go ahead and solve for c if we want to. That would be what? E to the 0 times 4 equals 0 e to the 0 minus e to the 0 plus c, which that means we get 4 minus 1 plus, 4 equals negative 1 plus c, which means c is equal to 5. And so I'm going to get, and we can go ahead and divide everything through by e to the x. That's going to give me y equals x minus 1 plus c e to the negative x. All right, and then we're going to replace the c with the 5. So y is equal to x minus 1 plus 5 e to the negative x. And there's your solution. All right. All right, so what about this one? Let's solve this one. This one we have a piecewise function for f of x. All right. So basically all we're going to do is we basically have two equations to solve. So we're gonna do the case where 0 is between x and 1. So that means we've got dy dx plus y is equal to 1, right? F of x is equal to 1 there. And so now I've got p of x is equal to 1. Integrating factor is e to the integral of 1 dx, which is equal to e to the x. So we're going to multiply each term by the integrating factor. And so this is d dx of the integrating factor times y, which is equal to e to the x. And so now I have the integral of d dx of e to the x y dx equals the integral e to the x. And so I've got e to the x y equals e to the x plus c. And so I've got y is equal to 1 plus c, e to the x. All right. Now, and I tell you what, let's call this C1 because we have another one to solve, and we'll call that constant C2. But notice here, they tell us y of 0 is equal to 0, and see, this is a case where x can equal 0. So if we do the fact that y of 0 equals 0, well, that's going to be 0 equals 1 plus c1 e to the 0, which tells us c is equal to negative 1. So we get y is equal to 1 minus e to the x. All right. So what we have here is we have y is equal to, so right now we got 1 minus e to the, oh, wait a minute, let's see. Oh, I messed that up, didn't I? I divide everything by e to the x. And so I move that up. That's going to become a negative x. Okay. And this is 0 less than or equal to x less than or equal to 1. All right, so now let's come up here for the case where x is greater than 1. So for x greater than 1, we've got dy dx plus y is equal to 0. All right. So of course we've got p of x is equal to 1. Our integrating factor is e to the integral 1 dx, which is just e to the x. And so e to the x dy dx plus e to the x y equals 0. So d dx e to the x y equals 0. And so if I integrate both sides, e to the x y, e to the x times y dx equals the integral 0 dx. So e to the x y equals c. So y is equal to c e to the negative x. Whoops. And let's call that, I forgot again, let's call that C2. All right. So this would give me C2 e to the negative x, and this is for x greater than 1. Oh, okay. So, all right, so let's look at this. So that the function is continuous at x equal 1. The requirement we have a requirement that the limit as x goes to 1 from the right, the limit of this as x approaches 1 from the right of y of x is equal to y of 1. That has to be the same thing when it's evaluated at 1. All right, so this means that, let's see, how do we want to do this? That means that C2 e to the negative x has to equal 1 minus e to the negative 1. We're plugging the 1 into here, and this has to be the same as this. See, if we plug the, if we're taking that limit. All right, and I wrote this wrong. You got to plug the one in, dummy. Okay. All right, so what we're doing is we're plugging the 1 into here, and so these two have to be the same. Okay, they have to be the same, and so that means that C2 equals 1 over e to the negative 1 minus e to the negative 1 over e to the negative 1. And so this tells us that C2 is equal to, that's going to be e minus 1. And so what we're going to do is we're going to replace C2 with e minus 1. So we get we get y is equal to 1 minus e to the negative x. And I'm sitting here forgetting to write things because I'm trying to do too many things in my head. I just need to stop doing that and write everything out. And there you have it. And this is continuous on 0 to infinity. We're going from 0 all the way to infinity. And so there's your solution. All right, we got one more example. Just hang in there with me. All right. All right, so error function. Two special functions are the error function and complementary error function. So the error function, which we write like this, ERF of x, is 2 over the square root of pi times the integral 0 to x e to the negative t squared dt, and ERFC of x, 2 over the square root of pi x to the infinity times the integral of x to the infinity of e to the negative t squared dt. All right, from the known result that, okay, there's a known result that e from the integral from 0 to infinity e to the negative t squared dt is square root of pi over 2. Okay, we can write that this is equal to 1, because if this is equal to square root of pi over 2, then 2 times that would be 1. And then from properties of definite integrals, we know that if we're going from z to infinity, we can actually split that up into two integrals, going from z to x plus x to infinity. Okay, you've done that many a times. Okay, so if we have 2 times the integral, okay, 2 times the integral 0 to infinity e to the negative t squared dt, that's equal to, and all I'm doing is breaking that up into this. Okay, I'm going from 0 to x and 0 to infinity of the, and 0 to x and x to infinity of this integral here. I'm just splitting the integral up, and we know that's equal to 1. Okay, and that's this. See, this is equal to 1, and I split it up, so I know that's equal to 1. So that tells us, see, this is just the error function, and this is the complementary error function. So we can say that these two added together are 1. And then let's make a note that the error function evaluated at 0 is 0. All right, so with all that being said, let's look at this example. All right, so it's in standard form. Okay, it's in standard form, and I've got p of x is equal to negative 2x. So my integrating factor is e to the integral negative 2x dx. So that's going to give me e is, that's going to be what? E to the negative x squared. And that's my integrating factor. So let's multiply it to each term. So I get e to the negative x squared dy dx minus 2x e to the negative x squared y equals 2e to the negative x squared. All right. Okay. So now we've got d dx times e to the negative x squared y is equal to 2e to the negative x squared. All right. Now, let's go ahead and do the integral of both sides. All right, so we've done this before. Okay, we have done this before. Okay, so just to refresh your memory. Okay, so this was done in the I think I did this in the previous video, separable equations. But if you remember, when you had a integral, because we've got to take the integral of this thing over here, okay? And if you remember, we had something that said y of all right, we had something that said y of x naught equals y naught. So if you have that, that's our initial, that's our condition there. We have that right here, y of 0, see y of 0 equals 1. We can say that y of x is equal to y naught plus the integral x naught to x g of t dt. Okay, we worked a problem like that in the last video. You can go back and watch that. I talk about it a little more in there. Okay, but that's what we're using here. We're using that dummy variable t. Okay, so we're going to integrate from 0 to x. See, in this case, your x naught is 0. And so that's going to be d dt, okay, of e to the negative t squared y of t dt. We're putting it in terms of t. And that is equal to 2 integral 0 to x e to the negative t squared dt. And so this is going to give us e to the negative t squared y of t from 0 to x equals, and that's going to be 2 0 to x e to the negative t squared dt. See, we can't integrate this right hand side over here. All right, and then if we plug everything in, that's going to be e to the negative x squared y of x minus e to the negative 0 squared y of 0 equals, and that's going to be 2 integral 0 to x e to the negative t squared dt. All right, and so this is going to be e to the negative x squared y of x minus y of 0, right? This right here just goes to 1, equals 2 0 to x e to the negative t squared dt. All right, and what are we wanting to do? Well, we're wanting to solve for y, right? We need to solve for y. So what do we have here? Well, this is going to be e to the negative x squared y of x equals y of 0 plus 2 integral 0 to x e to the negative t squared dt. I'm putting all the steps out, okay? And then just to save me from having to rewrite all this stuff again, y of 0 is 1, right? It tells us that here, y of 0 is 1. So I'm going to change that to a 1. And now what I'm going to do, I got to get this by itself. So I'm going to multiply both sides by e to the negative x squared. Or, I'm sorry, divide everything by that. Or I can multiply by e to the x squared. So I get y of x is equal to e to the x squared times 1 plus 2 integral 0 to x e to the negative t squared dt. All right. So here we are here. Okay. See, I divided this by e to the negative x squared and divided all of this by e to the negative x squared. So when you move that up into the numerator, it becomes e to the positive x squared. That's how I got that. All right. Now, if we look at this thing here, this looks familiar, doesn't it? It looks like where is it? It looks similar to this. See, we're going from 0 to x. We got a 2 here. The problem is we don't have that. Okay. So let's just go ahead. Let's just go ahead and write our error function down so we can actually just see it down here. So we've got that is equal to 2 over the square root of pi from 0 to x e to the negative t squared dt. Okay, so that's the error function we had written up there, and you can see that this right here and this right here are they almost look the same. We need a square root of pi down here. So what if we multiply this thing right here by square root of pi by square root of pi over square root of pi? So this would be what? Square root of pi, right? And then let me move this over. Okay. So this I'm going to multiply by square root of pi out here. All right. So all I did, I multiplied by this. I just put the denominator under the 2, and I put the numerator out here times that whole thing. And so now I get y is equal to e to the x squared times 1 plus square root of pi. And then what is that? Well, that's my error function. And there's your answer. Okay. See, this part right here is your error function. All right. So I hope that helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.